In this video, we're going to go through the second assignment for section 7.7 and 7.8 combined. So in this one, we have to start with number 4, and this is one of those binomials that is a difference of two perfect squares. So we have to use the difference of two squares pattern. So let me write down the problem here. I have z squared minus 81. And again, that does fit the difference of two squares pattern because this is the same thing as z squared minus 9 squared. So the difference of two perfect squares. So if I need to factor a squared minus b squared, it factors into the quantity a minus b times the quantity a plus b. So instead of putting a minus b, I'm going to put z minus 9 times, instead of a plus b, I'm going to put z plus 9. All right, so that is the factored form because we're not able to factor either of these factors any farther. There's no greatest common factor, and they're not the difference of two squares anymore. On number 6, we have 25 minus 4x squared. Again, this is the difference of two squares pattern. This is 5 squared minus the quantity 2x squared, because 2x times 2x, or 2x squared, gives you 4x squared. So a squared minus b squared, a is 5 and b is 2x. So where you see an a, you plug in a 5, where you see a b, you plug in a 2x. So this factors into 5 minus 2x times the quantity 5 plus 2x. And I know I said this a lot in the last video, but if you change the order of these factors, you will still get the right answer. So if you had 5 plus 2x times 5 minus 2x, that is still correct. The commutative property of multiplication says it's okay to change the order. You still get the same result. All right, number 8, the last one in this little section of problems. Number 8 is 16x squared minus 169y squared. Again, this is the difference of two squares pattern because you could rewrite this as 4x quantity squared minus 13y quantity squared. So 4x quantity squared is 16x squared. We have our subtraction, and then 13y quantity squared is 169y squared. If you didn't know that 13 squared was 169, you could take out your calculator, type in 169, and take the square root, and you get 13. So 13 squared is 169. All right, so on this one, this is your a value, 4x, and this is your b value, 13y. So where you have an a, you plug in 4x. Where you have a b, you plug in 13y. So this binomial factors into 4x minus 13y times the quantity 4x plus 13y. And that's it. That's the factored form. All right, moving on, we have to go to number 42. Number 42. All right, give me a second to get over there. Number 42, the grasshopper problem. So on 42, what we're going to have to do, it says the function represents, this function right here represents the height in feet of a grasshopper jumping straight up from the ground t seconds after the start of the jump. After how many seconds is the grasshopper 1 foot off the ground? All right, so we're given an equation. Now it says after how many seconds is the grasshopper 1 foot off the ground? And y is the number of feet. So if y is the number of feet and we want to know after how many seconds, we want to solve for t. When y is 1, we just plug in 1 for y. So I'm going to write down my original equation. Y equals negative 16t squared plus 8t. It's representing the height of the grasshopper. And then it says the height again is 1, so I need to plug in 1 for my height, or y. And then I'll have to solve this equation. So remember, in order to solve an equation like this, we need to get it equal to 0 because ultimately we're going to factor and then use the zero product property. So I'm going to subtract 1 from both sides of the equation, which would give me negative 16t squared plus 8t minus 1. And then I'm going to factor the right-hand side. So do I have a greatest common factor in this one? Well, I've got a negative leading coefficient, so I'm going to factor out a negative 1 and get 16t squared minus 8t plus 1. Because if I redistribute that negative 1, I would get what I started with. If you don't factor out the negative 1, you will still get the right answer. But technically, that is a greatest common factor. So I'm going to factor it out. And then I need to factor this trinomial into the product of two binomials. So what times what gives you a 16t squared? Well, we have some options here. We could do 16t and 1t. We could try 4t and 4t. I'm going to go with 4t and 4t and see if I can get that factored form. The last two numbers here have to multiply to a positive 1, but I've got a negative in the middle, so I'm thinking I need a negative times a negative, which gives me a positive. And the only way to get a 1 is a 1 and a 1, so that's nice. So let's double check. Do these binomials multiply to give me that trinomial? So FOIL them out. So multiply the first two, you get that 16t squared. The outside two, you get a negative 4t. The inside two, another negative 4t. They combine to give you negative 8t. And the last two give you a positive 1. So this is the factored form. And now in order to solve this, we'd have to set all the factors equal to 0. So the zero product property says if the product equals 0, then one of these factors must equal 0. Well, with this one, negative 1 will never equal 0, so you don't have to worry about that one. And the other two are the exact same thing. So the only option here is that 4t minus 1 equals 0. That is the only option. There is no other way to make the product equal 0 because there are no other factors. Okay, so looking at this one, I add 1 to the other side, so I get 4t equals 1, and divide by 4, I get t equals 1/4. So the answer here is 1/4 seconds, or 1/4 second. That is when the grasshopper is 1 foot off the ground. All right, going on to the second part of this assignment. We have page 407, starting with numbers 4 through 8 even. So on pages 4 through 8 even, on page 407, we have numbers 4 through 8 even. With numbers 4 through 8, we have to factor the polynomial by grouping because it is all of these are 4-term polynomials. So number 4 is y cubed minus 9y squared plus y minus 9. And again, to factor by grouping, we group them with the first two terms and the last two terms. And we take out the greatest common factor in each sets of terms. So the greatest common factor between y cubed and negative 9y squared is y squared. What remains when you factor out a y squared or divide out y squared from each of these terms? You have a y minus 9. You can double check that by distributing back in the y squared. So you have y squared times y is y cubed. Y squared times negative 9 is negative 9y squared. Do the same thing with the last two. What is the greatest common factor between those two terms? Well, on this one, between y and negative 9, there are no greatest common factors that exist between y and negative 9 other than a 1. There is always the possibility of a greatest common factor of 1. So I can take out positive 1. So what remains when you take out a positive 1? Well, positive 1 times y is y. Positive 1 times negative 9 is negative 9. So you have the same terms. The reason we have to write this plus 1 still is because we're ultimately trying to factor out a greatest common factor between these large terms, which in this case is a y minus 9, and that will help us get this into factored form. So what remains when you factor out y minus 9 from this large term, and that's a y squared, and from this large term, there's just a plus 1. All right, now is this factored completely? Well, we can't take out any more greatest common factors here between this y and negative 9. There's no greatest common factor here, and this is not the difference of two squares, so this is the factored form, and this is our answer. Going on to number 6. On number 6, 2s cubed minus 27 minus 18s plus 3s squared. This is not in standard form, but that is okay. We can still factor this by grouping. We just group the first and last two together. We're going to take out the greatest common factor between each of these terms. So between the first two terms here, there is no greatest common factor other than taking out a 1. So I'm going to take out 1 and say what times 1 gives me this? Well, the same thing, 2s cubed minus 27. Between the last two terms, the greatest common factor would be a 3, so I can put plus 3. But look at this. What we end up with is 6s, a negative 6s plus s squared. Oh, excuse me. I could take out a 3s. There we go. And we'd end up with a negative 6 plus s. Well, obviously, the value in parentheses here is not the same. So what's happening? Well, because it was not in standard form, we were not able to take out a big enough greatest common factor to give us the same quantity in parentheses here. So let's back up a little bit. Let's get rid of this. And before we try to factor by grouping, let's put it in standard form and see what happens. All right, so the greatest degree goes first. This has a degree 3, so this 2s cubed goes first. This has a degree 2, so this 3s squared goes next. The degree 1, negative 18s, goes next, and the degree 0 with the constant, negative 27, is at the end. Now let's factor by grouping. So let's group the first two and the last two terms together. And now if I take out the greatest common factor of an s squared, I would get 2s plus 3 left over. And between these two terms, the greatest common factor is a negative 9. So then I get a positive 2s plus 3 left over, because negative 9, if you redistribute it, would give you those two terms. And now you can see that we have the same terms inside of the parentheses here, so that is a greatest common factor between the large terms. So it turns out we did have to put this in a standard form in order to move forward. So the greatest common factor between these two terms, it kind of looks like a 25, that's an S. The greatest common factor between these two terms is 2s plus 3. So we're going to factor out 2s plus 3. And what remains from this large term is an s squared, and from this large term is the negative 9. Be careful on this one though. This right here is the difference of two squares pattern. So we do have to keep moving, we do have to keep factoring. So we're going to factor s squared minus 9 into s minus 3 times the quantity s plus 3. And now we are factored completely, and this is the factored form. All right, the last one in this little section is number 8, I believe. 4 through 8 evens, yep, number 8. On number 8, we've got q squared plus q plus 5pq plus 5p. All right, so again, is this in standard form? Well, we have a degree 2, degree 1, degree 2, degree 1. So this is not in standard form yet. However, if you look at these, we've got p in both of these, 5p in both of these terms, and we have a q in both of these terms. So let's try to factor this without putting it in standard form again, and just to see what happens. So between the first two terms, let's factor out the greatest common factor, which is q. What would remain is a q plus 1. And between the next two terms, the greatest common factor is a 5p, and what would remain is a q plus 1. So on this one, you get the same quantity in those parentheses, so it is okay to move forward with it the way that it's given to us, even though it's not in standard form. On the previous one, we got stuck when we tried to use the original expression, so we had to put it in standard form to try to move forward. All right, so in this one, if you take out the greatest common factor between the two large terms, you take out a q plus 1 because they both have a q plus 1. What remains is a q plus 5p. And that is the factored form. All right, for the next little section of questions here, we have to go to 11 through 15 odds. 11 through 15 odds. So on number 11, we have 2x cubed minus 2x. And the directions say factor completely, but again, we always want to factor completely. So let's try to factor this. The greatest common factor between these two terms is a 2x. What remains is in x cubed, x squared, because 2x times x squared is 2x cubed, minus 1 because 2x times negative 1 is negative 2x. So that's the first step, but again, we have the difference of two squares pattern right here. So I'm going to make a note of that again. This is the difference of two squares pattern. That is the difference of two squares, so we're going to apply the difference of two squares pattern, and we get 2x times the quantity. This factors into x minus 1 times the quantity x plus 1, and that is the factored form. All right, number 13. On number 13, we have a trinomial 2c squared minus 7c plus 19. A trinomial factors into the product of two binomials. The first two positions have to multiply to 2c squared, so that must be 2c times c. The last you have to multiply to a 19, but my middle term is negative, so I'm going to need a negative and a negative. And the only way to get 19 is 19 and 1, so either 19 goes here and 1 goes there, or vice versa. So let's see, if I put 1 here and 19 there, and just double check this, I get 2c squared minus 2c minus 19c. That does not combine to a negative 7c. So I could try the other possibility, 19 and 1, put a 1 here and a 19 there. But then I'm going to get 2c squared minus 38c minus another c. That is not negative 7c. So neither of those possibilities work. So I'm just going to show that this one didn't work, and 2c minus 19 and 2c c minus 1 did not work. So if you try all the possibilities and none of them work, what we say is that it is not factorable or unfactorable. Not factorable. And there was no greatest common factor, so we couldn't do anything to factor this. This is not factorable. All right, I believe we had to do number 15, 11 through 15. Yep, so number 15. On number 15, it is 6g cubed minus 24g squared plus 24g. So we have a greatest common factor in this one. So they all have g, they're all even coefficients. So there's definitely a greatest common factor. So what goes into 6 and 24? Well, 6 goes into those values. 24 is divisible by 6 because you get a whole number. When you divide 24 by 6, you get 4. All of these terms have at least one g in them, so 6g is the greatest common factor. What remains when you factor out 6g? You get g squared minus 4g plus 4. Again, you can double check that by redistributing the 6g and you get back to the original trinomial. All right, so on number 15, we've got a trinomial here that we need to factor. So that's going to factor into the product of two binomials if it is factorable. The only way to get g squared is g times g. And then we have a 4 on the end, but a negative in the middle, so I need two negatives. And I could use 2 and 2, 4 and 1. Let's see, I'm going to need 2 and 2 because g times g is g squared. The outside would give me a negative 2g, the inside a negative 2g. Those would combine to negative 4g, and the last 2 gives me that positive 4. So this is factored form. Because I have the same quantity here, I could rewrite this as 6g times the quantity g minus 2 squared. And just to show you here on number 15, that is how your authors write their answers as well. So if you have a quantity squared, if you have a quantity times itself, you should write it as a quantity squared. So if you check the back of the book while you were trying this problem and that's what you saw, that is how you get that. All right, 24 through 28, those are the last problems that you had to do, and you do have to do all of 24 through 28. So let's get to that. It's 24 through 28. Starting with number 24, it says solve the equation. So we have k to the fourth minus 100k squared equals, k squared equals 0. So on this one, we have an equation, so we can solve. But we're going to do the same thing. We always want to look for that greatest common factor first. So what is the greatest common factor between these two terms? And that is k squared. What remains when you factor out a k squared is a k squared minus 100, and it still equals 0. This is the difference of two squares pattern right here. So we're going to factor that into k minus 10 times the quantity k plus 10. So notice that I've slowly started to drop out how I'm explaining some of these steps, like the difference of two squareds. I'm no longer going to say, at least I will hardly ever say, that this is k squared minus 10 squared, and it's k minus 10, k plus 10, because it's a squared minus b squared equals a minus b, a plus b. I'm going to start dropping out a lot of that work. So if you're not sure on how I'm getting these, you might need to go back to previous lessons. But I want to start to speed up a little bit because ultimately I want you to try to speed up a little bit. And if you're still taking a while to get through these problems, that's okay. Keep practicing. But my goal is to have you speed up so by the time you get into Algebra 2, after we review all of this throughout all of geometry, I want you to be really quick at factoring, especially the difference of two squares pattern. All right, so let's move on. So we have the product equaling 0. So the zero product property says one of these three must equal 0. So that's one thing I'm going to stop saying as much now as well. So we have either k squared equals 0, k minus 10 equals 0, or k plus 10 equals 0. So we need to solve all three of these. So for the first one, we would take the square root of both sides. The square root of a variable squared is the absolute value of that variable. But ultimately, there's only one solution to that equation, which is k equals 0. Here we add 10 and get k equals 10. And the last one, we subtract 10 and get k equals negative 10. So my solutions in numerical order are negative 10, 0, or 10. All right, going on to number 25. I need to make this a little bit bigger here. So on number 25, we are given x cubed plus x squared equals 4x plus 4. So in this one, I need to make it equal 0 to apply the zero product property. So subtract the 4x from both sides of the equation, subtract the 4 from both sides of the equation, and this is the equation that it becomes. I have a 4-termed polynomial, so I'm going to factor these by grouping. Factor this by grouping. Take out the greatest common factor between the first two terms. I'm left with an x plus 1. The greatest common factor between the next two terms is a negative 4, and I'm left with an x plus 1. This is factorable, and I know that because I got the same quantity, x plus 1, in those parentheses, so I can factor out the x plus 1. What remains is an x squared minus 4, which is actually the difference of two squares pattern. So we can factor that into the quantity x minus 2 times the quantity x plus 2, and it still equals 0. So one of those three factors must equal 0 since their product is 0. So either x plus 1 equals 0, x minus 2 equals 0, or x plus 2 equals 0. Solving this one, I would get x equals negative 1. Setting this equal to 0 and solving, I get x equals 2. And setting this one equal to 0 and solving, I get x equals negative 2. In numerical order, writing my solutions, I get negative 2, negative 1, or 2. Number 26. I have 2t to the 5th plus 2t to the 4th minus 144t cubed equals 0. All right, so on 26, take out the greatest common factor, which is 2t to the 3rd, or 2t cubed. What remains is t squared plus t minus 72 equals 0. So we need to factor this trinomial. So that trinomial is going to factor into the product of two binomials. I need to multiply the last two to get a negative number, so I'm going to have one negative and one positive. T times t is t squared, and I need two numbers that multiply to negative 72. So I could try 36 and 2, but that's not going to give me that positive t in the middle. So let's say 72 divided by 6 and 12 will not work. 18 and 4 will not work. 3 and 24 won't work. 9 and 8, those will work. 9 and 8. All right, so 9 and 8, I get t squared plus 9t minus 8t gives me that positive t in the middle, and a negative 8 times positive 9 is negative 72. All right, set each one of your factors equal to 0 and solve. So 2t cubed equals 0, t minus 8 equals 0, or t plus 9 equals 0. So to solve this one, divide both sides by 2, you get t cubed equals 0. To undo a cubed, you need to take the cube root of both sides. And the cube root of 0 is 0, because 0 times itself 3 times is still 0. This one, you add 8 to both sides, you get t equals 8. This one, subtract 9 from both sides, you get t equals negative 9. So your solutions in numerical order, negative 9, 0, or 8. All right, numbers 27 and 28 are the last ones to do. So number 27, just double check this one more time, 27, 28, yep. 27 is 12s minus 3s squared, 3s cubed equals 0. Factor out the greatest common factor, which is 3s. What remains is a 4 minus s squared, and that still equals 0. Here you have the difference of two squares, 2 squared minus s squared, so this is 2 minus s times the quantity 2 plus s. That still equals 0. Set your factors equal to 0 and solve. So if 3s equals 0, you would get s equals 0. If 2 minus s equals 0, you would get s is 2. And if 2 plus s must equal 0, then s would equal negative 2. In numerical order, I've got negative 2, 0, or 2. All right, and going on to the last one, number 28. Number 28, 4y cubed minus 7y squared plus 28 equals 16y. All right, so get that set equal to 0 so we can factor and then apply the zero product property. So subtract 16y from both sides. Now, when I subtract it to the left-hand side here, I'm going to just put this right away into standard form. So 4y cubed minus 7y squared minus 16y equals 28. What am I doing? Plus 28 equals 0. All right, 4-term polynomial on the left side here, so factor that by grouping. Group the first two and last two terms together and take out the greatest common factor. In this one, the first two terms, the greatest common factor is y squared. You have a 4y minus 7 remaining. In the last two here, I can take out a negative 4, and what remains is a 4y minus 7. Because negative 4 times 4y is negative 16y, and negative 4 times negative 7 is a positive 28, so that still equals 0. So if you try to take out a positive 4, what would have happened is you would end up with a negative here and a positive there, and then you don't have the same quantity inside of the parentheses. So that is why I needed to ultimately take out a negative 4. So now I've got that same quantity in parentheses here, so I can factor that out. That's a greatest common factor between these two large terms. So I can factor out the 4y minus 7. And what remains from the first term is a y squared. And from this next term is a negative 4. That is the difference of two squares right here, y squared minus 2 squared. So I can factor that using the difference of two squares pattern into y minus 2 times the quantity y plus 2. And that still equals 0. All right, one of the three factors must equal 0. So on this one, if you set 4y minus 7 equal to 0, add 7 to the other side, and divide by 4, you get y equals 7/4. I'm going to write that as a mixed number, so that is y equals 1 3/4, or you could put 1.75. For the next one, if you set that one equal to 0, y minus 2 equals 0, you're going to get y equals 2. And for the last one, y plus 2 equals 0. Subtract 2 from both sides, you get y equals negative 2. So in numerical order, your three solutions are negative 2, 1 3/4, or positive 2. And that is it. Have a great day.